Find the mean of the data distribution. To start, to find the mean, you have to add all the values together. So we'll add 1.2, 5.8, 4.3, 6.1, and 2.2 together, giving us 19.6. Then you divide by how many data values there were. And in this case, there were 5. Which gives us a mean of 3.92. So again, add all the values together and divide by how many values there are. Consider the chance experiment of flipping a fair coin. Write a sequence of heads and tails that could occur if you flip the coin 20 times. So we're going to write a list of H's and T's for heads or tails, and we need to think about if we were to flip it 20 times. So just make a list. Maybe you think it's going to land on head, then tails, then maybe tails again, then head, then head, then head, then tails, then tails, then head, then tails. So I have 10 so far, and then we need 10 more to get to 20. And so we've just created a list. This is a prediction of what might occur. But in problem 2, we're going to actually flip a coin and record the sequence of heads and tails that does occur. How is the sequence that we found by actually flipping the coin different from the one that we predicted? In mine, I did not expect there to be 4 heads in a row or having 3 tails in a row necessarily. I predicted that I would have fewer duplicates than this. By flipping the coin, we're using what's called a random sample. And by using a random sample, we eliminate aspects of bias. When we think about the order of the heads and the tails, we know in our mind that we should get about half of the time heads and the other half tails. So our list in problem 1 has bias in it because we are thinking about how we shouldn't get a bunch of heads in a row. However, with a random chance, it's possible that we get multiple heads in a row. In your book, you have a poem on page 173, and it lists off how many are in the row. So if we're looking for word 8, it would be alas. If we were looking for word 9, it would be the first one in the next row. So we're going to select 8 words from this poem. I will select caged, through, joy, things, bruised, throbs, and perfume. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Oh, I need one more. River. So select 8 words from the poem. And list them in Part A. Then we need to also record the number of letters in each word that we selected. Caged has 5 letters. Joy has 3. Sings has 5. Throbs has 6. Through has 6. No, 7. Bruised is 7. Perfume is 7. And river is 5. Then we need to find the mean. So we're going to add those values together. Which is 45. And then we need to divide by 8 because there are 8 values, which is 5.625. This dot plot shows how many letters are in all of the words of the poem. What do you think is a typical value for the words in the poem? I'm going to assume that it's somewhere in the middle of 3 and 4. You can see that the majority of the data is collected around this area, so a typical amount of letters is somewhere between 3 and 4 letters in each word. Now we're going to use a random sample from the poem to help us. With this random sample, we should get closer to the actual typical or mean number of letters in the words of the whole poem. So I'm going to use this random number generator to help us generate some word numbers here. I saw in the poem that there were 186 words total. So our first one is word number 94, then word number 62, 55, 13, 64, 160, 32, and 139. So word 94. Let's see, this would be 88, 89, 90, 91, 92, 93, 94 is the word on. Word 62. 61, 62, that's the word no. 55, 53, 54, 55 is also the word no. 13, 8, 9, 10, 11, 12, 13 is the word bright. 64, 1, 2, 3, 4, the word the. 160, but. 32, that would be 27, 28, 29, 30, 31, 32, and 139. This would be word 140, so 139 would be bosom. How many letters are in these words? That would be 2, 4, 4, 6, 3, 3, 1, and 5. Now we need to find the mean. So you're going to start by adding all of these values together. Just the numbers of the letters. Don't worry about the word number. That was just used to help us figure out where in the poem the word was. So 2 plus 4 plus 4 plus 6 plus 3 plus 3 plus 1 plus 5 is 28. And then we need to divide by 8 because there are 8 values, which is 3.5, which is a lot closer to our expected measurement of what was typical for the poem. If we looked back at our dot plot, 3.5 falls right in line with what we were expecting. So when we use a random sample, it eliminates some of that bias, and it should get us closer to the actual average of the whole poem. Using a random sample is better than selecting things by hand.